Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So far we have seen the definition of function in depth in my previous video that I will link it up here for you to watch if you haven't watched my previous video. But today's video is the continuation of that video wherein I'll cover a few more topics related to functions. These are nothing but what is the domain of a function, codomain of a function, range of a function, difference between codomain and range, and also the interval notation that you need to use in order to define a range or a codomain or a domain in a function. So without wasting any more time, now let's jump right into the video. In my previous video, we have seen the exact definition of a function. I hope you understood the relationship between a function and a relation and the definition of a function. We have defined the function from A to B as, this is the notation of the function from A to B, wherein the values of A, every value of A will have a unique image in B. That is the definition of function that we know. Think of it like this way. So if you have any machine for that matter, washing machine or printer or anything for that matter, what you do in order to make the machine work, you need to give some input to it, right? And then the machine will perform the operation that it is intended to perform, and then it will produce the output as per whatever you expect, isn't it? That is what a machine's job is. The operation that the machine performs is a function. And the input values that you give to a machine is called domain. Domain is the input that you need to give to a machine in order to perform a particular function. And the output that you get after putting the values in the machine or in the function is range. So domain is the input to a function and range is the output to a function, right? So for example, A, B, C is the domain, you get the output as E, F, G. So for A you will get E, for B you get F, for C you get G. There is a unique image for every value of A. That is a function. And these values are known as inputs. The inputs are known as domain, and the output that you get after you plug in the values into the function is nothing but range. So what we usually do when it comes to the problems related to function is that you will either have to find out the domain of a particular function. That means you need to find out what values can that function take in order to produce a valid output. And you might sometimes have to get the range by plugging in the values that you have the domain and figure out. Right. This is the concept of domain, and we represent the domain in the form of interval notation. We use the interval notation to represent the domain or a range or a codomain of a function. We'll see that in depth in a short while, but before that, let's now try to understand the concept of codomain. So, there is a subtle difference between range and a codomain. It is much emphasized in all your textbooks. Range is the output that you will get, the exact output that you will get when you plug in these values. However, a codomain is the values that you might possibly get when you plug in a few inputs. After you plug in these values into a function, you might probably get these values as the output, but they might or might not be the exact values that you get after you plug in these values. That is the difference. So now let's tackle the difference between range versus codomain. As I've explained you about range is nothing but the value, the output that you get after you plug in a particular input value. Okay, that is very clear for you. Now codomain is the superset of range. That is, range is a subset of codomain. Codomain is nothing but a set of all the possible values that you might get when you perform an operation on a function by plugging in a few input values. These are the possible values, but they might not be the actual result, as in all the possible values might not contribute to the actual output of the function. That is the subtle difference between range and codomain. The codomain will help you restrict the output of a function. It will say that this is the set, this is the codomain, your range should fall, or your range should be a part of this set, but it cannot be beyond this set of values. That is what a codomain says. Let's now tackle these three with one example. For example, I would say A is equal to 1, 2, 3, 4 and B is equal to 1, 4, 9, 25 and 64. Okay, now f of x is a function that is x square and f is defined from A to B. So here, this is the question that I give you. What we'll do is, you know for a fact, in order to perform the function, you need to input the values in A and you need to get the output, right? Here, he has given B as this set here. He has given them as what? 1, 4, 9, 25, 64. And he has given the values of A as what? 1, 2, 3, 4. Okay. So, if you substitute the values of A in this function f of x is equal to x square, what will you get? F of 1 is 1, f of 2 is 4, f of 3 is 9, f of 4 is 16. So, you will get these values as output, whereas these are all inputs to the function, right? And these are all the outputs. If you see the codomain here, I've told you that this is the codomain, that is, these are all the possible values that you might get after you perform an operation on a function by inputting a few values. So, how many values does the range have right now? You have 1, 4, 9, 16 as the range, right? And codomain, you know for a fact that range is a subset of a codomain. That means range can take only those values that are present in the codomain. The values that are not present as a part of the codomain will not be satisfied by this function. That is the definition of codomain. This is how it restricts the output of a function. It will say that you need to get the values that are in this set. If you get any value that is beyond this set, then it is not possible to use that value as a part of the function. Okay, so if there are any values that are out of the set, then they are not included in the range. So in here, we saw that this is the range. So range is nothing but the values that you get after you input all the values in the domain. So, this is the range. Now, this is the codomain. What are the values that are present? So, whatever values that are present in the range, after you apply the operation, do you think these are there in the codomain? Let's check. 1 is there, 4 is there, 9 is there, but 16, it is not a part of codomain. So, what do we do then? We will just eliminate the value 16 because it is not there in the codomain, hence it will not be present in the range. Therefore, the range of the function f of x can be 1, 4, 9 but not 16 because it's not there in the codomain. And now this satisfies the definition that range is a subset of codomain, which means all the values in the range must be present in the values of the codomain. So, this is the range. Okay, so this is the difference between range and codomain. So, in order to write the domain and a range of a function, you will use interval notation to represent it. So how do you actually write the domain or range of a function in the form of interval? What you do, whatever is the smallest value of that interval, you put it towards the left side. If you say this left and this right, separate the two by comma. A 0 is the smallest value here. Put the smallest value towards the left, and infinity is the largest value if you say for that interval. Then this is how you write. Put the smallest towards the left and largest towards the right. And square brackets means you are including the smallest value also within that range. And close brackets, that is the parentheses, means you are excluding the last value. In here, infinity is infinity, we don't know the last value, so we just put parentheses here. But if you say this is the range, this is the domain, then you will say that, okay, fine, my domain starts from 0, but it ends at 1. It will not include 2. If you say you are only taking positive integers. Okay, if you are taking the decimals, then it will go on 1.99999 and whatever. If it tends to 2, that is the value, but 2 cannot be the value of that interval. Okay, now let's using these concepts tackle these inequalities. What is x greater than a? Can you not say here that x takes all the values starting from the value that is after a? That means a should be close brackets because we don't want to include a. So it should be parenthesis and it will go on until infinity. Okay, so what is the graph on the number line? If you say this is the number line, you say a is somewhere here. This is the graph. It will go on to this. This is how you represent x is greater than a. Now, quickly, x is less than a, it means it starts from minus infinity to a. That means it will take, x can take any values that is less than a but does not include a. So that's why you use parenthesis, and it is nothing but, here you can say, these are all the values of a, x. Okay, now what is x is greater than equal to a? It means that you need a in your interval to infinity. That means you need to include a while writing an interval, or while you are writing the domain you need to include a. So how do you represent this? There is subtle difference you need to know. Here we are not including a, so whatever comes right after a will be the notation. Here whatever comes right below a will be the notation. Here you can say you will start from a, this will be included, along with this you will say these are the values that x greater than or equal to a will take. Well, now what is less than or equal to? Here you say minus infinity comma a. Because we got equal to here, we need to include a. Now it will take, you can say a here, and it will start from a, it will go to the negative side. Right. Now a is less than x less than b. That means our x should be between a and b, but it should not include a and b together. If we want to include, we'll get the possibility of a less than equal to x less than equal to b. So what do we do here? We should not include, right? So we just put it as a comma b. That's it. So x, the value of x ranges from a to b. It should not include a, b. It should be between this. Okay. Now a less than or equal to x less than b. How do you write this? You write this as a. We want to include a. Wherever is equal, it should say we want to include a, but we don't want to include b. So you can say, sorry, a, b. We want to include b, but we don't want to include b. This is a comma b. And then you can say this as, we don't want to include a, but we want to include b. So you can define this as, we want to include b, but we don't want to include a. Okay. And last but not least, we want to include both a and b. So the graph will be all the values between a and b, including a and b themselves. This is how you write the interval notation of these inequalities. This is how you represent domain and range in all your functions after finding what exactly should be the domain and range of a function. It's imperative for you to understand the interval notation. You can fill in the descriptions whatever we have just saw. Okay, So this is the discussion on interval notation. I hope you understood the concepts taught in today's video, which are very important, that is domain, range, codomain, the differences between codomain and domain, codomain and range, and also the interval notation that you need to understand in order to find or represent a domain and a range of a function. So in the next video, we'll see how do you find the domain of a function and what are the things that you need to keep in mind in order to write the domain. It depends on the function itself. Okay, so I hope you understood the video so far. If you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. I will see you all in my next video. Until then, I hope you have a safe day and a wonderful week ahead. Bye.